Right, we are starting chapter 27. This is covering pages 515 to 517. So the colors that we see are actually just dependent on the frequency of the light we see. Remember that there are tons of frequencies of light that we cannot see in the electromagnetic spectrum, and 1/1,000,000th of 1% of light is visible to our eyes. So the colors that we see are all dependent on the frequency of light and what light is being bounced off of those opaque objects. So remember, transparency depends on the frequency of the object and the frequency of the light. If it's transparent, it will flow through it. And if it is opaque, it bounces off. And so the light frequency that bounces off is what we see. So the lowest frequency that is seen by most people is the color of red. I say most people because not everybody can see the color red. And the highest frequency that we can see is generally the color violet. Now, keep in mind that there aren't just the colors of the rainbow. There are an infinite number of hues that make up the color spectrum. It's not a divisible red, orange, yellow, green, blue, indigo, violet. They're not broken up exactly and specifically like that. They blend together. So there are an infinite number of hues, kind of like when you open up your 103 pack of Crayola crayons. There's an infinite number of hues. You can't even break it down to 103. There's so many more than that. We usually group them into 7 colors, basically red, orange, yellow, green, blue, indigo, violet. If you don't know the colors of the rainbow or Roy G. Biv, go ahead and memorize that. That's something that all adults should know, just saying. And together, those 7 colors form what we would say is white light. So white light is actually all the colors of light combined together to make white light. Now, most objects are going to reflect light rather than emit it. Almost everything that you look at in your room, in your classroom, in your car while we're driving around, they're not actually emitting light. They are not shining forth a light. They are only reflecting the light that is bounced off of them. Similar to how we're not salvation, we are not the source of any of that. All we can do is reflect the glory of the Lord around us. So we are reflecting light. The light that is bouncing off of us and into our neighbor's eye is what they can see of us. So the objects, the light that's bouncing off, they reflect a frequency of light, and that light gives us its color. So if it is something that is red, like a rose, it's not emitting red light. It is just reflecting the red light back into your eye. What happens to everything else? It absorbs it. So anything that you look at that is red, it's absorbing all the other colors. And red, the low frequency, is being bounced off of it and back into your eye. And that's what we see as it being red. All right? So if you shine any other color of light, if you have just that colored light on a red rose, and you don't have any other light coming in. So that's one of the things that we'll do in class. Part of the problem with actually seeing it is that there are other white lights being emitted into the classroom, which allows some of the color to bounce off. But if you were in just a blacked out room and you were shining a green light on a red rose, those petals would be either brown or black colored because those petals absorb the blue light and bounce none of it back. The only thing it bounces back is red. So if an object is reflecting all the light that shines on it, like a piece of paper, that is going to be the same color as the light that is shined on it because it bounces everything off. So if you have a white sheet of paper in your blacked out room and you shine that blue light on it, that paper is going to look blue because the blue bounces off. If you shined a green light on it, the green would bounce off. It would appear green. If you, shine in whatever color it is, if you shined it on there, it's going to bounce it back and that's what it's going to look like. But if it's an object that we see as a specific color, if you shine a color of light other than that color of light on that object, it's going to appear black or brown. So that red rose, if you shined a red light on it, it's going to look red because the red bounces off. Any other color, it's not going to look red. It's going to look black or brown because it absorbs the color rather than bouncing it back. So if you absorb all the light that is shined, then you're going to appear black. So that is why a blue ball with a red light shined on it is going to appear black or brown, is because it's absorbing that red light because it only bounces off blue. Now we define an object's true color as the color it has out in the sunlight. So if you've ever noticed in your closet, picking out clothes, you think two colors match in the light of your room. And then when you go out into the sunlight, you're like, wow, those blues really aren't the same blue. It's because its true color is going to be the color that we would define as it as being in daylight. So the color of any transparent object is going to depend on the color of light it transmits, right? So we're not reflecting light anymore, we're letting light through. So like stained glass windows, you've got the blue glass and the red glass and the green glass and the yellow glass. Those transparent objects are going to depend on the light that it lets through. So a piece of glass that contains dyes or pigments, they absorb certain frequencies and allow the others to transmit. So blue glass appears blue because everything else is absorbed and blue is let through. That's why it looks blue. Just like a blue shirt looks blue because it absorbs all the other colors and bounces blue off into our eye. Blue glass appears blue because it absorbs all the other colors and lets blue out. Now, when something is absorbing these frequencies, it is going to increase the kinetic energy inside that item. So a black shirt is going to feel hotter because it's absorbing all of the light frequencies that are going on there. Nothing is bouncing back off. So it's going to increase your kinetic energy there. So colored glass is going to absorb more energy than clear glass. Click on the link, complete the homework quiz, and I'll see you in class. Have a good night.